Well, hi. Today I am going to talk about the quadratic function. So, for this exposition, we created a problem about a robotic arm that must be situated into a factory and is supposed to transfer parts from a conveyor belt to an assembly station. So, the movement of our robotic arm is set by this function here, where, as we already know, f of x or y is supposed to represent the vertical position of our robotic arm, and x represents the horizontal position of our robotic arm in centimeters. So, formulation of the equation. We get the f of x is a quadratic equation, a quadratic function, so it is a polynomial of the shape ax squared plus bx plus c, where every part of this function has a function. For example, here we have that ax squared controls the curvature, makes the arm follow a downward parabola. Why? Because we have this minus. It means our parabola, we have the vertex, and the vertex will open downwards. That's what this minus means. We also have this 3x, gives the initial upward movement of the arm. Something interesting of this point is that when we equal x to 0, the slope of that point will be 3. Such like a linear equation, but just when x equals to 0. Also, we have this 2, that when we equal x to 0, we get that our initial position will be 2. It means that our initial point is 0.2. Here we have our function again. Well, we have something interesting right here, because if we look, we have that this is the domain, but we have two domains. We have the physical domain, that's right in here, from 0 to 6.6, but we have also a mathematical domain. Why? Because the mathematical domain is from minus infinite to infinite, but our robot arm isn't infinite. It has to be physical. So the physical limitations of our robotic arms made this domain from 0 to 6.6. Something similar happens with our range, where we have a mathematical range of minus infinite to 6.5, but our physical range is just from 0 to 6.5, because we will say that this 0 into the vertical axis will be like the floor, so our robotic arm is not supposed to go below the floor. Next. So we have also the slope. We have here a huge difference between the quadratic function, and the linear function. Why? Because while in the linear function we get a constant slope, in the quadratic function we have to get the derivative of our function, and to get the slope of a specific point we have to replace x by that point. For example, we want to know what is the slope when x equals to 0. That's exactly this thing here. I explained that here. The explanation is that our slope will be 3. If we want to know what is our slope when x equals 1, we get that is 2. Yeah. We have also some intercepts. We have a vertical intercept when we equal x to 0, y2, and we have two x-intercepts, but we will just take this one because the second one is out of our domain, our physical domain. This one is into our domain, but the second one is out because it goes from 0 to 6.6, and this is minus 0.6, so it's out. Also, we have the vertex. It's supposed to be the highest or the lowest point of our parabola. For this situation, it's the highest. Applied to our function is this 3. So when x equals 3, we get our highest point. And we also have the symmetry axis. We just need to draw like a parallel line, a line parallel to our y-axis, and it has to cross the vertex. We have here our symmetry axis. I drew this symmetry axis just for our physical proportions. It should be from minus infinity to plus infinity in a regular function, but I just took the physical proportions of our robotic arm. And thank you. So also we can look a little closer on graphic. Yeah. Here we have it, the vertex, the x-axis, good one, and this one is out of our physical domain, and this is our y-axis cut. And that's all. Thank you very much.